Hi everyone, today we are going to see organic nitrogen compounds part 2. So in part 1 we discussed about the nomenclature and the introduction part and how to prepare primary, secondary, tertiary and quaternary amines, right? So now, same methods of preparation of amines by reducing agents, right? By reduction process. Over here, first one from cyanide. How to prepare amines from cyanide by using cyanide. Over here, the reducing agents which we are using, lithium aluminum hydride and sodium in the presence of ethanol, like ethanolic sodium, and hydrogen. Whenever we use hydrogen, we have to use catalyst, nickel or platinum catalyst. Yeah. So over here, the first thing, an alkyl cyanide, when it reacts with a reagent, reducing agent, the reducing agent supplies hydrogen. Over here, that shows 4 hydrogen. So that means one of the hydrogen binds with, 2 of the hydrogen binds with carbon and 2 of the hydrogen binds with nitrogen, which shows RCH2NH2, which means if it is a ethane nitrile, what is ethane nitrile? Methyl cyanide, right? The methyl group with cyanide. So the hydrogen binds with cyanide group. So over here, carbon with 2 hydrogen, nitrogen with 2 hydrogen, which leads to ethanamine, right? CH3, CH2, and H2, ethanamine. If it is with benzene ring with cyanide, phenyl cyanide, that leads to phenyl methanamine, right? So over here, something important to know, if you use sodium, ethanolic sodium, as a reducing agent, we call this process as Mendius process, Mendius reaction. Okay. Next, by reduction of isocyanide. So cyanide is RCN, isocyanide is R group with NC. So N triple bond C and one of the bond I put arrow which is coordinate bond, right? Okay. So RNC. So over here the hydrogen binds with the nitrogen and carbon atom as we have seen in cyanide, right? Over here one of the hydrogen binds with the nitrogen and 3 other hydrogens binds with carbon atom, which means RNHCH3. If N has only 1 hydrogen atom, we call it as secondary. So by reducing isocyanide, you can prepare secondary amine, right? So for example, over here methyl isocyanide we have. So CH3NC on reduction. Over here you got CH3NHCH3. So which means that this carbon atom got 3 hydrogen. So which over here methyl. So N-methyl methanamine, which means 2 methyl group with NH. So we call it as dimethylamine, which is a secondary amine. Okay. Same thing applies over here too. And over here phenyl isocyanide, same concept. Over here nitrogen will get 1 hydrogen, carbon binds with 3 hydrogen. So this shows N-methyl benzenamine, right? Which is N-methyl aniline. Same concept. And the synthetic importance over here is by using KCN, alcoholic KCN with the alkyl halide, you get RCN, which is alkyl cyanide. But over here, when alkyl cyanide on reduction, which leads to primary amine with 1 more carbon atom. Over here, number of carbon atom increases. Let's say, for example, it is CH3Cl, methyl chloride. When methyl chloride binds with KCN, so over here, what happens? So chlorine displays by K, chlorine reacts with K, which goes as KCl. So the alkyl group binds with CN, which means you get CH3CN. So from methyl chloride, you got ethane nitrile. And ethane nitrile on reduction, you get ethanamine, which means one more carbon atom increase over here, right? So this is the synthetic importance. But over here, Hoffman's degradation is the other way around. Here you will remove one carbon atom from the reactant. But the reactant is ethanamide, alkanamide. Okay, alkanamide, which means CONH2. So in CONH2, by adding bromine, with the help of caustic potash, over here the reaction takes place. 4 potassium over here, the 2 of the potassium binds with CO3. I mean the 4 oxygen over here, which goes as K2CO3, and 2 other potassium binds with Br, which goes as 2KBr, and you get methanamine as a product. Over here, what is the use here? The product containing one carbon atom less than the amide. Whatever you amide you use, if you use propanamide, you get ethanamine. If you use butanamide, you will get propanamine, right? So one less than the amide. So it is very useful in stepping down a homologous series, right? Okay, so same thing with example, with different examples I've given here. Let's move on to the next topic. From nitro compounds. What is nitro compound? Nitroalkane, nitromethane, CH3NO2. So in nitromethane, by using reducing agents over here, tin with HCl, iron with HCl, lithium aluminum hydride, hydrogen in the presence of a nickel or palladium or platinum. Over here, these leads to amine. So over here, see NO2. So oxygen displaced by hydrogen. So how will you displace oxygen? When hydrogen binds with oxygen and it goes escapes as water molecule. So which means there are 2 oxygen. If you want to remove 2 oxygen, you need 4 hydrogen. So 2H2O. So as 2 moles of water molecule it goes, and the rest, the other 2 hydrogen binds over here, which gives us amine. So this is how, if you see the example over here, nitrobenzene with 6H, which means 4 hydrogen goes as water molecule, and the 2 hydrogen binds over here, which forms aniline. Okay. And the important thing over here is one of the most convenient method to prepare aromatic primary amine, because we cannot be prepared easily from haloarine. Okay, so one of the most convenient method to prepare aromatic primary amine, right? Okay, next, which is nitro hydrocarbon. I mean nitroalkanes. Okay, by Gabriel Thalamide reaction. By Gabriel Thalamide reaction, one of the naming reaction, very important naming reaction over here. How you get thalamide, you should know. So to get thalamide, we need phthalic acid, which is benzene ring with 2 COOH. So phthalic acid, when it reacts with ammonia, let's say 2 moles of ammonia. So that you'll understand here, 2 moles of ammonia binds with hydrogen over here, which forms ammonium phthalate. By heating this ammonium phthalate, okay, what happened? One of the hydrogen with 2 hydrogen goes as same way over here, goes as water molecule. So which means 2 moles of water molecules last year, so which leads to thalamide. And over here, by strongly heating this mixture, NH3 escapes, NH2, and one of the hydrogen over here escapes. So which leads to thalamide. Okay, so once you get thalamide, by using thalamide, you can prepare alkyl amine. So over here, thalamide, when it reacts with alcoholic KOH, over here, see the reaction, the hydrogen displaced by K, potassium, right? So over here, when alkyl halide, over here, C2H5I, ethyl iodide. When you use ethyl iodide, whenever halogen and alkyl, alkali metal is there will be a reaction with these 2 elements. So potassium reacts with I and goes as potassium iodide, so that the alkyl group binds with N, right? So if you see here, the note over here shows C6H5Cl leads to benzylamine. So over here, C2H5I mean ethyl iodide leads to ethylamine. We use benzyl chloride, which leads to benzylamine, right? Okay. So this leads over here, ethyl group displaces the potassium. So it goes as potassium iodide. And over here, by adding water, this leads to, over here, it dissociates into C2H5NH2. In the presence of dilute HCl, what happens? You get ethylamine. So ethylamine, and you get phthalic acid from water molecules. OH from water molecules binds over here, which gives phthalic acid and ethylamine. As I told you, if you use benzyl chloride, you get benzylamine, right? Okay, chlorobenzene leads to benzylamine. Yeah. Physical properties of amine over here, physical state and color. So lower amines and higher amines and aromatic amines. Lower amines like methylamine, ethylamine, these are colorless gas which has a smell of ammonia. And higher amines like more than 3 methyl groups, right? So higher amines are colorless liquids, and all other amines are higher. Other than methylamine, dimethylamine, trimethylamine, or ethylamine, other than all other amines are higher amines, which smells like fish. Okay. And aromatic amines, colorless solids or colorless liquids. Okay. So have characteristic, or each the substance has different smell characteristic smell. So they turn brown in air due to oxidation, right? When it oxidizes, it turns brown. Solubility, aliphatic amines, aromatic amines. Aliphatic amines are soluble, and the reason is which forms hydrogen bonds with water. And the solubility decreases when the size increases, when MR increases, when the number of alkyl group increases. So over here, aromatics are sparingly soluble. Over here, aniline dissolves to some extent, but other aromatic amines are insoluble in water. And so these compounds, aromatic amines, are soluble in benzene, ether, and alcohol, which means it dissolves in organic solvents, right? Okay, boiling point. Hydrocarbon has a less boiling point when compared to amines, but when compared to alcohol and acid, it has less. The reason is over there hydrogen bonding with the oxygen, which is more electronegative than nitrogen. That's why. Okay, so primary amine, secondary amine, tertiary. When you compare with these two, primary has more boiling point, right? Over here, explanation. I've given here amines are polar except tertiary amines. So over here, I've given a few examples for that. Primary amines have 2 polar. The reason is N has CH3, N bonded with 2 hydrogen. Nitrogen bonded with 2 hydrogen. 2 replaceable hydrogens are there. That's the reason. And secondary amines over here, which has 1 replaceable amine, right? And tertiary is also polar because of nitrogen, because nitrogen has a lone pair electron over here, right? But still it is polar, but over here unable to form intermolecular hydrogen bonds because there is no replaceable hydrogen over here, absence of NH bonds over here. And due to intermolecular hydrogen bonds, primary and secondary amines have higher boiling point. Okay, so over here, because of the when compared to C2H5NH2 and CH3NHCH3 and CH3NCH3CH3, what are these? Primary amine, secondary amine, tertiary amine. But why they have given these 3 as example over here? Because these 3 have similar mass numbers, MR value more or less similar. So when the MR is similar, same MR value, more or less same MR value. When there is the same MR value over here, what is it? The boiling point of primary amine is higher when compared with other amines, right? Okay. So over here, in amines, hydrogen bonding is through nitrogen atom, which is less electronegative than oxygen. That's what we have seen already. And the boiling point of amines over here, Alcohols and acids are higher because of this reason, because of the hydrogen bonding present in alcohols and the acids. And the rest we will see in the next part. Thank you. Bye-bye.